Good morning, afternoon, or evening. How y'all doing today? Welcome back to Morrow's Math Corner. Today we're going to learn how to solve absolute value equations and inequalities. So let's get right to it. Let's first go back in time and let's try to remember that the absolute value describes the distance from zero. So since it's a distance, it's always going to be positive. Remember that. Also remember that the absolute value is represented by the following symbols. It looks like two parallel lines. Now, when solving absolute value equations, remember that it's going to be a very easy process. But you must remember that an absolute value has a positive and a negative side. Now, you may be saying, wait a second, Mauro, you just said that the absolute value is always positive. And it is, but it's got a positive and a negative side. For example, if I were to tell you that the absolute value of x is 3, x could be 3, which is the positive side, or x could also be negative 3. Now, the answer is 3. That's the absolute value. But the x itself could have been positive or negative 3. Let me explain why. Since absolute value is a distance, if you're here at negative 3, and it's a distance from 0, you got to go 1, 2, 3 positive units to get to 0. If x is positive 3, it also has to go 1, 2, 3 positive 3 units to get to 0. So regardless if x is negative 3 or positive 3, it is positive 3 units away from 0. Okay, so it's very important to understand. Now, how does it work? Knowing that absolute values have two sides make it much easier to solve absolute value equations and inequalities. Let's go ahead and examine the solutions of absolute value of 2x plus 6 plus 8 equals 12. I want you to graph and check your solutions as well. Sometimes you will solve for a value that does not work when evaluated. If you remember this happened to us in the past. These solutions are called extraneous. So those are answers that do not work. So let's get to the procedure. First and foremost, we're going to isolate the absolute value. So we want the absolute value alone by itself. So in this example, we're going to go ahead and subtract 8 to both sides. And now my absolute value is by itself. You may say, wait a second, but there's stuff going on inside the absolute value. Yes, but there's nothing being multiplied to it on the outside, divided to it, or added or subtracted to it anymore. Now, step 2, this is the most important part. You're going to split the equation or inequality into a positive and negative side. What does that mean? That means you're going to multiply the non-absolute value side by negative 1. Please note that if you are working with inequalities, you must flip the inequality sign of the negative side since you are multiplied by a negative, okay? So we're going to go ahead and split this up into a positive side, which I call the mirror image because it's exactly the same, but we're getting rid of the absolute value sign. And then the negative side, which is 2x plus 6 equals negative 4. Why negative 4? Because let's look again over here. You're going to multiply the non-absolute value side by negative 1. So 4 times a negative 1 is negative 4. Step 3, solve both equations or inequalities. So I'm going to subtract 6 to both sides here, giving me 2x equals negative 2. Divide by 2 to both sides. X equals negative 2. The other side over here, we subtract 6 to both sides. We've got 2x equals negative 10. Divide 2 to both sides. X equals negative 5. And there you have it. My solutions could be either negative 2 or negative 5. But remember to always check. How do we check? Plug it back in. 2 times negative 2 is negative 4, plus 6 is 4. The absolute value of 4 is 4, so that works. Let's check negative 5. 2 times negative 5, if that was the x, would be negative 10. Negative 10 plus 6 is negative 4. The absolute value of negative 4 is 4, so it also works. And there you have it. It's that simple. All right. Starting from 100 feet away, your friend skates towards you and then passes by you. She skates at a constant speed of 20 feet per second. Her distance d from you in feet after t seconds is given by the formula d equals the absolute value of 100 minus 20t. At what times, that would be the t, is she 40 feet from you? Well, let's go ahead and plug in. We're looking for the time t, but they gave you the distance d. So this would be 40 equals absolute value of 100 minus 20t. The absolute value is already by itself. It's isolated, in other words. So we're going to have a positive side and the negative side. The positive side is the mirror image, which is 100 minus 20t equals 40. The negative side is 100 minus 20t equals negative 40, because once again, we're multiplying the non-absolute value side by a negative. Now we're going to solve both sides. So I'm going to subtract 100 to both sides, giving me negative 20t equals negative 60. Divide by negative 20 to both sides, and t equals 3. And then I'm going to subtract, and that should be a 40 there, sorry, negative 100 to both sides. Negative 20t equals negative 140. We're going to divide by negative 20 to both sides, and t will also equal 7. So that means that after 3 seconds and then again 7 seconds, your friend will be 40 feet away from you. Let's check to make sure that this works. Well, if we check 3, okay, 100 minus 60, okay, if t was 3 seconds, negative 20 times 3 is negative 60. 100 minus 60 is 40. The square root of the absolute value, rather, of 40 is 40, so that works. Let's check to see when x is, or t is 7. Well, if t is 7 here, that means that negative 20 times 7 is negative 140. 100 minus 140 is negative 40. The absolute value of negative 40 is 40, so it also works. Okay. Let's solve. First thing we're going to do is we're going to isolate the absolute value. So I'm going to add 5 to both sides. And we've got the absolute value of x minus 6 equals negative 2. And guess what, my friends? If you remember the definition, the absolute value is the distance from 0. That means that the absolute value must always equal a value greater than or equal to 0. So therefore, an absolute value can never equal a negative. So therefore, in this case, it's no solution. Remember that. An absolute value must always be greater than or equal to 0. If not, it is a no solution. Okay, next. We're going to isolate the variable here, so we're going to, or the absolute value, so we're going to subtract 3 to both sides. I've got the absolute value of 2x minus 1 equals 9. Now I'm going to go ahead and split that up into my positive side and my negative side. My positive side is 2x minus 1 equals 9. It's the mirror image. My negative side is 2x minus 1 equals negative 9 because I multiplied the non-absolute value side by negative 1. Now I'm going to solve both sides. Add 1 to both sides. I've got 2x equals 10. Divide by 2 to both sides. X equals 5. And then on the other side here, I also add 1 to both sides. 2x equals negative 8 divided by 2. So x can also equal negative 4. Let's test them. All right. If x equals 5, 2 times 5 is 10, minus 1 is 9. The absolute value of 9 does equal 9, so that works. If x equals negative 4, 2 times negative 4 is negative 8, minus 1 is negative 9. The absolute value of negative 9 is 9, so that works. All right, what happens if you have two absolute values? Well, me personally, I'm a creature of habit, so I'm always going to go ahead and when I'm splitting up into the positive and the negative side, I'm going to multiply a negative to the right side. You could do it to the left side if you wanted to, but I'm a creature of habit. So what do I mean here? The positive side is just the mirror image. 8x plus 11 equals 6x plus 17. But on the negative side, please remember what I said. I'm going to multiply this whole entire absolute value. That means I'm going to distribute a negative 1 to everything inside that absolute value. So that will render me with 8x plus 11 equals negative 6x minus 17. So now let's solve. So I'm going to go ahead and subtract 6x to both sides here, and I'm going to subtract 11 to both sides, leaving me with 2x equals 6 divided by 2. X can equal 3. Over here on this side, I'm going to add 6x to both sides. I like to keep my x's positive. I'm going to subtract 11 to both sides. So that gives me 14x equals negative 28. Divide 14 to both sides, and I've got x equals negative 2. So x can equal 3 or negative 2, but let's test it. All right, so let's get rid of this here. Okay, if x equals 3, 8 times 3 is 24. 24 plus 11 is 35. So I've got 35 here. Absolute value of 35 is 35. And then 6 times 3 is 18 plus 17 is also 35. Absolute value of 35 is 35. So that works. Okay. If x is negative 2, let's see if it works. 2 times, or rather 8 times negative 2 is negative 16. Plus 11 is going to be negative 5. Absolute value of negative 5 is 5. And then 6 times negative 2 is negative 12. Negative 12 plus 17 is 5. Absolute value of 5 is 5. So once again, they both work. Now let's look at inequalities. Inequalities work the same way. Just remember, whenever you're splitting it up into your positive and your negative side, the negative side must flip the inequality. So we're going to split this up because the absolute value is already isolated. So I've got n minus 1 is less than or equal to 2. That's my positive side, mirror image. And my negative side is going to be n minus 1 is greater than or equal to negative 2. Why did that flip, Moto? Because remember, I multiplied a negative 1 to the non-absolute value side. So whenever I multiply an inequality by a negative, I gotta flip the sign. So now let's go ahead and solve. I'm gonna add 1 to both sides. N is less than or equal to 3. Gonna add 1 over here to both sides. N is greater than or equal to negative 1. Now let's test it. What's a value that's less than 3? I don't know, 0. So let's choose for when n is 0. Let's see if it works. Well, if n is 0, 0 minus 1 is negative 1. The absolute value of negative 1 is 1. And 1 is less than or equal to 2, so that side works. Let's check now. When n is greater than or equal to negative 1. Greater than or equal to negative 1, let's say n equals 3. That's greater than or equal to negative 1. So if n equals 3 here, let's go ahead and plug in a 3 here. So 3 minus 1 is 2. Absolute value of 2 is 2. And 2 is less than or equal to 2. So that works as well. And bada bing, bada boom, Those are my solutions. Now, here's the tricky part. When we're graphing this, the big question is this an and or an or? Well, we have n is less than or equal to 3. So we're going to have a bracket. We're going to shade over here less than or equal to 3. And then n is greater than or equal to -1. So we got a -1 here, greater than or equal to. We're going to shade to the right. And here's the trick. See how this is less than? Think about it like this. Less than. Anytime you have an absolute value that's less than, it will be an and. And if you remember, an and is an intersection. So where do you have the solutions intersecting? Right here in between -1 to 3 with brackets because they're also equal to. Less than. Now, if we look at our next example, we have a greater. Well, let's just go ahead and let the cat out of the bag right now. Greater means greater. So when you have a greater than or equal to, it's an or. Greater. All right, so less than and greater. All right, let's solve this. We've got our positive side and we've got our negative side. Our positive side, we've got 2x plus 4 is greater than or equal to 5. On my negative side, I've got 2x plus 4 is less than or equal to -5. On my positive side, I'm going to subtract 4 to both sides. I've got 2x is greater than or equal to 1. Divide by 2. So x is greater than or equal to 1/2. On my negative side, I subtract 4 to both sides. 2x is less than or equal to -9. Divide by 2 to both sides. X is less than or equal to -4 and 1/2. Now let's test them. What's a value that is greater than or equal to 1/2? Let's try x is 1. That's greater than. So I've got here, if x is 1, 2 times 1 is 2, plus 4 is 6. Absolute value of 6 is greater than. So absolute value of 6 is 6, and 6 is greater than or equal to 5, so that works. Next, let's check here. What's a value less than or equal to -4? Well, let's say -6. -6 is less than or equal to -4. Remember that the smaller the value, the larger the negative, the smaller the value. So let's go ahead and check when x is -6, if that works. 2 times -6 is -12. -12 plus 4 is -8. The absolute value of -8 is 8. And 8 is greater than or equal to 5. So that also works. So bada bing, bada boom. X is greater than or equal to 1/2. So we've got 1/2 here, and it's greater than or equal to. So we got bracket, and you're shifting to the right. And then at the same time, x is less than or equal to -4 and 1/2. So that's less than or equal to, so we're shading to the left. And since this is a greater than or equal to, remember it's an or, so my solutions are -infinity to -4 and 1/2, bracket in union with bracket 1/2 to positive infinity. And there you have it. It's that simple. All right, last part. Let's do some word problems. A company makes boxes of crackers that should weigh 213 grams. A quality control inspector randomly selects his boxes to weigh. Any box that varies from the weight by more than 5 grams is sent back. What is the range allowable for the weights of the box of crackers? Okay, So what is the range allowable of weights for a box of crackers? This is how you want to always set up absolute value word problems. You have x minus the desired or goal is less than or equal to the change or variance. A variance means that it's varying by, it can change by that amount. So in this particular case, the desired goal is 213. So x minus 213, and it's going to be, can't weigh, okay, so we have weight by more than 5 grams. So we got less than or equal to 5, okay? So we've got our positive side and our negative side. Our positive side is x minus 213 is less than or equal to 5. And our negative side is x minus 213 is greater than or equal to 5. We're going to add 213 to both sides. So x has to be less than or equal to 218. And then we're going to add 213 to both sides. And I'm sorry, I messed up. On the negative side here, that's a negative 5 because you have to multiply that 5 by a negative 1. I apologize. So when I add that 213 over here, x has to be greater than or equal to 208. Now, it's a less than, okay? It's always going to be a less than for word problems. So it's an and. So that means when I graph this, okay, when I graph this situation here, we've got 0 over here, and I've got 208, and it's greater than or equal to, so I'm shifting to the right here forever, but it's less than 218. So that's a bracket, and I'm shifting less than. And where do we overlap? Because it's an and, it's an intersection. So that means that the weights of this can be between 208 grams all the way to 213 grams. And that's real life. They do this quality control with cereal boxes, cans of beans, tuna cans, anything that has a desired weight and can have a variance. Okay, a food manufacturer makes 32-ounce boxes of pasta. Not every box weighs exactly 32 ounces. Write and solve an absolute value inequality to find the range of allowable weights if there is an allowable error of 0.5 ounces. That is my variance or my allowable change. So I've got x minus the desired is less than or equal to 0.5. Let's go ahead and solve. And 0.5 again is my variance or my allowable error, my allowable change. So the positive side, I've got x minus 32 is less than or equal to 0.5. On my negative side, I've got x minus 32 is greater than or equal to negative 0.5. I add 32 to both sides. X is less than or equal to 32.5. I add 32 to both sides. And x is greater than or equal to 31.5. It is a less than. So when I graph this, here's my 0, here's my 31.5, and it has to be greater than or equal to 31.5, but at the same time, it must be less than or equal to 32.5. So that's a bracket, and you're going to the left. It's a less than, so we're looking for the overlap, the intersection of solutions. So my allowable weights here are between 31.5 ounces, comma, and 32.5 ounces. And there you have it. That's how you solve absolute value equations and inequalities. Hope you learned a lot. Thanks for watching. Come back anytime. Take care now. Bye-bye.